Welcome to Vpod.ai. Just a quick note before we start. This deep dive is sponsored by Stonefly. They're your trusted solution provider and advisor for a whole range of things: enterprise storage, backup, disaster recovery.
Right. Hyper-converged VMware, Hyper-V, Proxmox clusters, AI servers.
SA365, that turnkey security appliance, and public and private cloud too.
Definitely worth checking them out at stonefly.com.
Okay, so today we're diving into something really fascinating in biomedical tech.
Yeah, it's a new angle on detecting heart attacks. Faster, potentially more accurate.
We're looking at work from researchers at the University of Mississippi. They're developing this lightweight, very energy-efficient chip.
Designed specifically for wearable devices. Think watches, maybe other things down the line.
And our mission today really is to explore how this tech could genuinely change things. Speed, accuracy, potentially saving lives.
That's the core of it. You know, with heart attacks, speed is just critical.
Time is muscle, right?
Exactly. Every second lost can mean more damage. And while the statistics are stark, someone in the U.S. dies from a heart attack roughly every 40 seconds.
Wow, every 40 seconds. That really drives home the urgency.
And heart disease is still the #1 killer. So, yeah, finding better, faster ways to detect these events is crucial.
So typically, how are heart attacks detected now? It's usually in a hospital setting.
Generally, yes. You'd get an electrocardiogram, an ECG, or maybe blood tests to run.
But that takes time. You have to realize something's wrong, get to the hospital.
Precisely. There's an inherent delay. Recognizing symptoms, travel, waiting for tests, all that eats up valuable time.
Which can lead to worse outcomes. Okay, so tell us about this University of Mississippi approach. What's the innovation here?
Well, the team, led by Assistant Professor Qasim Khalil, he's in electrical and computer engineering, they've taken a really interesting path. They've developed a chip that uses artificial intelligence.
AI, okay. We hear that everywhere, but how does it apply here?
And some advanced mathematics underpin it, too. Basically, the chip is designed to constantly analyze ECGs.
The heart's electrical signals.
Right. But using AI algorithms, it learns to spot the subtle signs of a heart attack in real time. Patterns that might indicate something is wrong, happening right now.
So it's like having a continuous intelligent monitor.
Sort of, yeah. Think of the AI as being trained on tons of ECG data. It gets really good at picking up these tiny anomalies, even amidst all the noise of everyday activity, which a simple device might miss.
Real-time analysis from something you wear. That does sound like a game changer. What about performance? Does speed compromise accuracy?
That's the really interesting part. It seems not. The report suggests it could be up to twice as fast as the usual method.
Twice as fast.
Yeah, and while maintaining a very high accuracy rate, they're reporting 92.4%.
92.4%.
Ah.
That's impressive. Is that better than current methods?
In many contexts, yes, especially considering it's designed for a wearable. Getting that kind of accuracy outside a clinical setting as well, it's a significant step.
Faster and potentially more accurate. That's key. I also heard the researchers really focused on the design itself, making it practical.
Absolutely. Professor Khalil's team knew it had to be more than just clever science. It needed to be, practical, lightweight, economical, low power usage, all crucial if you want people to actually wear it comfortably, continuously.
Right. It has to be wearable in the real sense of the word, not some clunky lab device.
Exactly. They really thought about the whole package.
And were there specific people focusing on different parts? You mentioned the AI.
Yeah, Tamador Mohaida, a doctoral student, really focused on that artificial neural network, the AI brain, so to speak.
Okay.
And another graduate student, Emelin Rahat Qadarkhan, built the software side, making the whole thing work together.
So a real team effort, hardware and software.
Seems like a very integrated approach.
Which brings us to the big vision. Embedding this in everyday wearables. Your watch, maybe your phone.
That's the goal, continuous monitoring right on your wrist or in your pocket.
Imagine getting an alert the moment a heart attack might be starting.
That's the potential transformation. Immediate detection could mean getting help much, much faster, cutting down that crucial delay we talked about.
The benefits for patients seem huge. Faster diagnosis means faster treatment.
And that's critical for limiting heart damage. The quicker you get treatment, the better the chance of recovery, of minimizing long-term effects.
It really brings that time as muscle idea right down to the personal level.
Absolutely.
And are they thinking beyond heart attacks? Could this kind of tech be adapted?
They are, actually. The researchers see potential for similar approaches, AI, wearable sensors for other conditions.
Like what?
Things like seizures, maybe even picking up early signs of dementia. Of course, the specifics would change.
You need different algorithms, maybe different sensors tailored to brain activity for seizures or other biometrics for dementia.
Exactly. The underlying principle of using AI to analyze complex biological signals in real time could be quite broadly applicable, but each condition needs its own specific solution.
Okay, let's sort of wrap our heads around this. For you listening, what's the takeaway here?
I think it points to a future where our personal tech plays a much more active role in our health. Not just tracking steps, but, potentially giving us critical, life-saving alerts.
Yeah, moving from passive tracking to active monitoring and alerting for serious events.
The idea of this tiny, efficient chip doing real-time ECG analysis with high accuracy, that feels like a genuinely significant leap in biomedical engineering.
It really does.
So it leaves you with a big question to think about, doesn't it?
Mhm.
As this kind of continuous, personalized health monitoring gets better and more widespread, how might it change everything? Not just how we react to emergencies like heart attacks, but maybe even how we approach preventative care altogether.
A future where your watch doesn't just tell time, but could actually save your life in a very direct way. Definitely something to ponder.